We're going over the trigonometry review. Let me remind you that the title is always in the top left. So whenever you have one of these, it's really important that you just confirm it is what it should be. A flagpole casts a 13-foot shadow on the ground. So we got a flagpole and there's a shadow, A-D-O-W, on the ground when the sun is at a 60-degree angle of elevation. So let's see, that would be something like this, where this is your 68 degrees. This is your sun. And here's that flagpole. Right. Sorry, that's an ugly looking flagpole, but there it is. Which of the following expressions can be used to determine the height in feet of the flagpole? So here's our height. Okay, so we got our shadow was 13 feet. It's a 13-foot shadow. All right. So we got this would be a right angle. Across from the 68 degrees is the opposite side. Next to the 68 degrees is the adjacent side. Adjacent. All right, and so let's use our SOHCAHTOA. SOHCAHTOA. Which of these has adjacent and opposite in it? If you need to, that's an O. That's an A. You're looking for an A and an O. That's your tangent right here. So tangent of our 68 degrees is equal to opposite over adjacent. And the opposite side is 13. The adjacent side is our height, h. So tangent of 68 degrees is equal to 13 over h. To a couple different ways we can do this. I like the reciprocal method. So 1 over tangent of 68 is equal to h over 13. Multiply both sides by 13 times 13, and we now have h is equal to 13 over tangent of 68 degrees. Okay, so let's go ahead and type that in. So I already have my calculator right here. 13 divided by tangent of 68, and confirm you're in degree mode. We are in degrees. So that's 5.252. 5.252 ... And all they wanted was the which of the following expressions can be used to determine the height h. So the height h, 13 over tangent of 68. Tangent of 68 equals, oh gee, we got cotangent in here. Cotangent is the reciprocal of tangent. So cotangent, gee, this is tough. Cotangent is equal to adjacent over opposite. Okay, it's just the flip of tangent. So that would be cotangent for this one. I don't see any others of 68 is equal to adjacent is h, opposite is 13. H over 13, cotangent. Sorry about that. That's a tough one. But we wouldn't, usually this problem would be done in the tangent sense. So all this work is definitely valid, and that's more of the direction that we're going in. All right. Right triangle QRS is pictured. So let's go ahead and go after it. Which equation gives the correct length of side RS? RS is right here, and they're calling it RS. Okay. Which equation gives the correct length of the side RS? Well, this is our reference angle. So this would be the adjacent side down here. This right here is the hypotenuse across from the right angle. And that's all we need. So ka, toa. The adjacent and hypotenuse. Which of these have adjacent and hypotenuse? There it is. So cosine of 31 degrees is equal to adjacent over hypotenuse. Adjacent is RS. Hypotenuse is 24.8. And cosine of 31 equals RS over 2. Yep, there it is right there. Find x to the nearest hundredth place. Okay. So mark all the sides. This is our reference angle. This is the hypotenuse. This is the across from the angle of reference is the opposite side. So we're looking for hypotenuse and opposite. So ka, toa. Which one has opposite and hypotenuse in it? There it is right there, sine. Sine of 65 degrees is equal to opposite over hypotenuse. The opposite side is 22. Hypotenuse is x. Sine of 65, we're in degrees, 22 over x. Do you remember how I did this? I like the reciprocal method, but might as well just go ahead and show alternate forms. That's since we're here. So I'll go ahead and to clear fractions or to get x out of the bottom, the next method would be to multiply by x. It's the clearing fractions method. Or just to multiply whatever you have on the bottom that you're trying to get rid of. The x I don't want on the bottom. So those cancel. I now have x sine of 65 degrees is equal to 22. Divide by sine of 65. Divide by sine of 65. And we get x equals 22 over sine of 65. And we're still in degrees. All right. So now I need my Desmos calculator. 22 over sine of 65. 22 divided by sine of 65. 24.274. 24.274 ... There it is right there. They want it to the nearest hundredths place, so let's be careful. Tenths, hundredths, this is the one I'm focusing on. I look at that number. It's smaller, so it gets truncated or dropped, and we get 24.27 rounded to hundredths. I'm kind of going through these a little too fast. I should read the question a little bit better. 24.27, got it. We'll go ahead and pick up here on the next video.